We are now going to continue our demo, and we're going to begin using the RNT interface to access the NetCDF files. Now, why would we want to use the RNT interface? Well, let's first open our main NC tutorial. And we're going to now work with tutorial number 3, which is the CTL array working with multiple NC files. And so the RNT toolbox has the ability to create something called the CTL array, which will allow us to actually work with multiple NetCDF files. Why is this useful? Let's go to the tutorial. And now let's go in the MATLAB window. Let's type ls. So up to this point, we worked with the NOAA sea surface temperature file, and this is one NetCDF file containing the sea surface temperatures. Now assume that you have a model output instead, and each model and the model may have a lot of output files, and that could be the case when, for example, you have a big model grid and you cannot store your entire model output just in one file. So this is an example of having two NetCDF files output of the model. So one way, of course, of opening these files is to say nc netcdf, and then you open file number 2, for example, and then you can actually, let's call this nc2, for example, and you can open nc1 as well. Okay, so now if I wanted to, for example, load the sea surface height of the first file, I would say zeta equals nc1 of zeta, and then I would load the entire sea surface height, which is a three-dimensional field in this case, and so then, you know, so this is like the typical statement of reading a variable. So this would be the zeta of the first file, and then I would read the zeta of the second file. And now suppose that I want to do an average of the two, so then I would have to put these variables together. Zeta average is going to be equal, you know, the mean of zeta, you know, zeta comma 3 plus the mean, say, of zeta. Anyway, you could see that, you know, if you wanted to work with the entire field, it starts to become cumbersome. I guess you can load, you could, for example, load the first zeta in this first variable, and this would be, in this case, let's see, there are 12 records, and then what you could do, you could load number 2 here and append it to this existing, so we could say 13 to 24, another 12 records, and we could do this, but then, you know, you could start getting errors because it's actually, so anyway, it's not very convenient to, if you want to work with one field and you have multiple files. And what if you wanted to access a particular time? You know, you have to load the time, you know, so then you start loading the time and so forth, you know, of this particular ROM's output, which would be, you know, this would be the time of the first file, but then you would also have the time of the second file, and so, you know, it becomes kind of a mess. So how to deal with all this? What you can do is first to create a structure, a cell array that contains the names of all the output files that you want to work with. Okay, so this would be in other words, it would be chronological order. So you have the two files, the first output and the second output. Okay, so we have this. Then we create something called the CTL array, and you do that by using this RNT times CTL routine that has as input argument the files, which is the list of output files, and the name of the time variable that is contained in these files, so that we're going to order everything according to time. So we go here, press F12, and now we have this CTL array. Now this CTL array is a map that basically tells you for each time, it knows exactly where each time record is located, either in this file or in this file. So for example, here you have time. This is the time of the model, okay, and it's in seconds. So if I divide that by 60, divide by 60, I get the days. Okay, so this is day 319,000, etc. Okay, so what is this output? In this case, this output turns out to be an output of a long-term run from 1950s to present, you know, of an ocean model. And so these are days from you know, starting 1950 of you know, from the 1950 of January 1950. Okay, so since I know that, I'm going to customize a little bit my CTL array, and I'm going to put a couple of arguments here. I'm going to say first of all that this time is actually ROM's time, and I'm going to put that as R. And in particular, my ROM's time by default, the way I'd like to do it, I have years that have 360 days. Okay, but you may have it in a slightly different way. And you can look at the help of this routine, and you'll find that there's a variety of other calendars that you can use. And then I'm going to say that my first day in this case is 1950. Is January 1950. So I'm going to put 00. It's the beginning of 1950. Okay, so I'm going to do this kind of thing here. And I'm going to execute this particular CTL. So now I have, again, the CTL hasn't really changed, but I have now these fields here, month and year. And so now I can actually check CTL year. And it turns out that this particular average file has records from 1986 to 1988. So it's about almost 2 years of data. And I also have the month information. Okay, so I have all this, everything is contained in this record. So for example, suppose that now I want to load the month 12, okay, which is the December month, and make an average of all the Decembers. Okay, so how do I do that? Of course, the Decembers will be some in this file and some in that file. Well, the nice thing of the CTL is that I really don't care. So all I do is then I can say zeta equals rnt load var. Okay, then I give the CTL, which is the map of the files and output, and then I put the indices that I want to load. For example, suppose I want to load index number 14, and then I say the variable that I want to load. Okay, so I say that, and so instantaneously I have now this variable. Now if I want to load all the Decembers, I can do en equals find ctl.month equals 12, which is the month of December, and it tells me that I have 3 records that are in December. So let me see if that's actually true. I thought there were more. No, there's actually 1 and 2 records. Okay, so now that I have this, then I can again use my rnt load var command, but I can put just the indices you know, that I just computed, and now I have loaded all the December values. Okay, and so now if I do a size of zeta, I have, you know, the December values. Now assume that I want to load the entire sea surface height value. Then I just do 1 to 24, the whole range of indices, and I can load them like this in a very simple way. If I want to take an average of that, I can do, I can take the mean here of this value. And I instantaneously have the average, and I never have to really open the individual files. I just use the CTL to access whatever portion I want. And in fact, I can make a figure now of this average, and this particular model run is for the NEPD grid. So I'm going to load this grid, NEPD, and I'm going to do in a figure, and then rnt PLCM of zeta, which is now this average, GRD. And let's see what this average looks like. This is what it looks like. Okay, so I've done that very easy, and I can also, of course, because I can load the whole thing at once, I can also compute the standard deviation and all sorts of things. If I want to load, for example, again, I want to look at the January average. Okay, I do this, and now instead of loading the entire thing, I just load en, and I can plot this this average. And so this is the January. Of course, these are only 2 records, but plausibly thinking, you could have, you know, a whole bunch of records. If you don't know which calendar you're using, which it could be the case, all you need to know is that the CTL array carries the actual time that was stored in the model in this field here, the CTL.time. This is basically the time that is in the ocean model. So you can just always use, you know, directly the time that is stored there and convert it to whatever calendar you want. And I typically like to convert this and then, you know, store the datenum format, and then the month, the year, and the day, if this is a long-term integration, for example, so that I can always know, for example, I can do things like date string of ctl.datenum, and I can get the, the actual dates. As you can see here, this is an average stored center around the 16th of the month. Okay. Now, if you want to find out more about the CTL array, you can do a help on this routine here, which creates the CTL array. And this is a long, it's actually not very long. And you have here, so the function and so forth. And it tells you some examples and stuff. Now, the idea of this array is very simple. You have a list of files, and then when you create this array, it creates a list of the indices here, you see, for each time record, and it makes a map, which is a segment map, which says where these indices are located. So for example, here it says that from index 0 to 12, these are located, for example, in the first file, and index 12 to 24, they're located in the second file. So if you have a whole bunch of files, then you can basically, I'll give you an example. This is I'm loading now the output of a long-term run that I've been working with, and where this, let me just load it. While it's loading, I just keep saying, so then you have, and then these particular structures are additional informations that you don't necessarily need to use the CTL array, but you may want to initialize so that you have them handy when you need them. So right now what I'm doing here, this is just a script that I load that basically creates the CTL now for my NEPD fork run. This is a long-term run, and it does it in the same way as we did here. It creates first a list of all the files. In this case, these are hundreds of files, so you'll see in just a second. And then it just execute the CTL string to create the CTL. So, for example, now this is the CTL of the full run. And if we do a return, now you see that we have about 2,197 records, and now you have 184 files. So, for example, if I do CTL file of 1, this is file number 1, this is the last file, so you see I have a whole bunch of different files. They're also stored in different directories, some of these. But anyway, so now, for example, if I want to load the January months, I can do en equals find ctl.month equals 1. And you see that now this is a big, it's 184 because this is it's many years. This is probably oh, this is a very, very long run. So suppose that I don't want to load all of them, but actually let's load them. So now we can load the January months average, and let's do that. It may take something. And now what it's doing is actually loading the January across a whole range of files, and you don't even have to worry where this January thing is stored. You just have to, you could just load it all at once. And hopefully it's not going to take too long. But this is a lot of data that we're working right now. And so let's wait just a second. Okay, so it's done. And now we can make a picture of this. And now you can see it's much smoother. And this is the January, mean sea surface height from this long-term run. This is the Northeast Pacific grid. Okay, and all this is very easy using this CTL array that we just described in this section. Okay, this is all for this demo.